Guys, so we finally come to the last one, horizontal asymptotes. So what are horizontal asymptotes? Well, they're an invisible horizontal line that your graph does not cross towards large number for x's. Meaning, if I have a graph right here, here's my x-axis, here's my y-axis. So if I'm graphing something here, let's say I have an invisible line right here at y equals 1, okay? And my graph looks something like this. Boom. Where my graph is trying to avoid hitting this invisible horizontal line towards large numbers of x's. So like maybe x over here will be, I don't know, like negative 100,000. And maybe x over here will be positive 100. Or rather, 1 million. So we're talking about a large number of x's that our graph does not cross at. But it is okay for our graph to cross this horizontal asymptote towards smaller numbers, such as maybe like -1, 0, something like this can occur. But notice, as we get larger and larger numbers that get close to infinity, our graph will not cross this dotted line. Also, as we choose numbers smaller and smaller close to negative infinity, our graph will come close to this dotted line, but will not touch that dotted line. So our goal here is to figure out how can we decipher if our rational function has a horizontal asymptote. Well, really, we're going to go by this concept right here. It's dependent on the degree of the numerator and the degree of the denominator. Now, if you guys don't remember, the degree of a polynomial, let's say I have a polynomial f of x equals x squared plus x minus 2. The degree of this polynomial will be the largest exponent that I see. So here, the degree of this guy, the degree of f, equals 2, right? Okay, so what if I had another function like this? G of x equals x squared minus 3 plus x to the 4th. Well, my polynomial might not be in greatest to lowest exponents, so I have to do some searching. What is my largest exponent here? It's this guy right here, 4, right? 4 is my largest exponent, therefore the degree of this guy, of g, is equal to 4. So don't just look at the first term here. You might mess up. Look at every single one of your terms and figure out which one has the largest exponent, and that will be your degree. Okay, so here are some of the rules for horizontal asymptotes. We got 3 of them. Well, 3 of them that we're going to go over. If the degree of your numerator is larger than the degree of your denominator, then there is no horizontal asymptote. The second one, if the degree of your numerator is less than the degree of your denominator, then the horizontal asymptote is at y equals 0. Lastly, if the degree of your numerator is equal to the degree of your denominator, the horizontal asymptote is located at a ratio of the leading coefficients. So to find your horizontal asymptote, you'd have to take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. And this will make a little bit more sense once we look at our examples, okay? So let's come here to example 1. So we have x cubed minus 1 divided by x plus 1. This guy right here, he's our numerator, right? So if I were to write the degree of my numerator, I would pick the largest exponent that I see. And that here would be 3. Good. Then I look at the denominator. What is the degree of my denominator? Now, a lot of people make this mistake of saying 0 because they don't see an exponent. But don't forget, there's an invisible 1 right here, right? So the degree of my denominator, ooh, that should be a denominator, not numerator. The degree of my denominator is 1. So what we have here is that the degree of the numerator is greater than the degree of the numerator is greater than the degree of the denominator, right? So let's see which rule we would have to apply. So we come up to our rules list, and where does it say degree of the numerator? Well, that's our first rule. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So if your question is asking you, what is the horizontal asymptote for this function? You say, none. I don't know. Just say doesn't exist. Okay. Okay, let's look at the second one. So the second one, let's do the same thing. So the degree of this guy is, again, well, it's actually the inverse of this guy, right? We just flipped around these two guys. We put this guy on bottom and we put this guy on top. So we can just flip them around. So this guy is 1, and the degree of this guy, the new denominator, is 3. So this time we have the degree of the numerator is less than the degree of the denominator. So let's see. Let's go back to our rules and look which one of these really applies to this question. Well, if the degree of the numerator is less than the degree of the denominator, we use rule 2. We say that the horizontal asymptote is located at y equals 0. Okay. So if they ask you where is the horizontal asymptote located, we would say at y equals 0. Why? Because the degree of the numerator is less than the degree of the denominator. Okay, lastly. All right, so now let's look at the degrees. We have x squared on top and we have x squared on bottom. So these degrees, they both have a degree of 2. They're the same, the degrees, right? So the degree of the denominator is equal to 2. So what do we do in this case? Well, if the degree of the numerator is equal to the degree of the denominator, I think I said that right, then the horizontal asymptote is located at y equals, so we say the horizontal asymptote is located at y equals the leading coefficient of the numerator. So what is the leading coefficient of this numerator? Well, here's my x with the largest exponent, and here's the term that's in front of it. So my leading coefficient here would be 3. So the leading coefficient of my numerator, and I'll divide that by the leading coefficient of the denominator. Well, this x is the highest exponent, and what number is attached to it in front? 2. So that means my horizontal asymptote is located at 3 over 2. All right, I'll see you guys in the next video where we look at these 3 exact examples, but on Desmos. All right, catch you there.